When you go out to buy a new car, you immediately look at the horsepower, right?
Absolutely. It's like the very first thing you check.
Exactly. You see, one vehicle has, I don't know, 300 horsepower and the other has 200.
And it makes the decision incredibly easy.
Right. You just point to the 300 and you say, well, there it is. That one is better. And you just drive off the lot.
Yeah. We are like so heavily conditioned to expect all our technology to come with this perfect spec sheet.
A spec sheet of just, absolute quantifiable supremacy.
It's a very clean, comforting metric. We want a hierarchy we can trust because it just makes decision-making effortless. You just buy the bigger number.
Right. You buy the bigger number. But, and this is the core of today's deep dive, the moment you step into the world of artificial intelligence, specifically large language models, that spec sheet becomes completely useless.
Yeah, it really does. It falls apart entirely.
We are staring at an evaluation landscape that is just fundamentally broken. I mean, if you log online or talk to colleagues right now, you constantly hear this endless, exhausting horse race about whether, Model A is better than Model B.
Which is, spoiler alert, entirely the wrong conversation to be having.
Exactly. And to explore why that is, we're using a single, incredibly concise piece of source material today.
It's a really fascinating one, too.
It is. It's this brief note written by Salali Banerjee. And despite being literally just a few lines long, it completely upends how we should be evaluating these AI tools.
It packs a massive punch for such a short text.
It really does. So our mission for this conversation is to use Banerjee's concept to basically unlearn our current benchmarks and, redefine our entire relationship with the technology.
Which is a big task, but Banerjee's opening provocation really hits the problem right on the head.
Yeah, the note argues that people love to claim Model A is better than Model B, but, and this is the kicker, that is simply not how learning works.
And that single word right there, learning, that is the pivot point for everything.
Right.
Because the moment we acknowledge that these are learning models, the entire hardware comparison we usually rely on just completely falls apart.
Let's unpack the mechanics of that, actually, because we treat AI like smartphones, right? Like, phone A has a better camera sensor than phone B.
Laptop A has more RAM.
Exactly. We assume these are static, physical realities. I mean, a camera lens doesn't suddenly change its physical properties based on what you're taking a picture of. It just, takes the picture.
Yeah. And that is exactly why the hardware mindset fails so spectacularly here. Because a large language model is dynamic.
Okay, dynamic in what way?
Well, when we desperately search for a static, universal best model, we're completely ignoring the unpredictable, highly contextual nature of how these systems actually process information.
Because they aren't calculators.
Exactly. They are not calculators. A calculator gives you the exact same answer to 2 plus 2, regardless of whether you punch the keys politely, angrily, or, I don't know, in French.
Right, the calculator doesn't care. It has a static operational capacity.
But LLMs, on the other hand, are probabilistic engines.
Okay, wait, pause right there for a second. Define probabilistic engines for me in this context. Because when I hear probabilistic, I just hear, oh, it's guessing.
Right.
Is the AI just rolling the dice every time I ask it a question?
I mean, it is a highly educated, mathematically complex form of guessing, yes.
Okay.
An LLM doesn't have, a hidden database of facts that it goes and looks up in a filing cabinet.
Like a search engine would?
Right. Instead, it predicts the most likely next word, and then the next word, based on the massive web of context you provided in that exact microsecond.
Wow.
So its reality actually changes based on your input.
Yeah.
Which means saying Model A is better than Model B in a vacuum is, well, it's essentially meaningless.
Okay, I see where you're going, but let me push back a bit here.
Sure, go for it.
If we look at the tech news, they are always talking about how many parameters a new model has, like trillions of parameters now.
Oh, yeah, the parameter race.
Right. So doesn't a model with more parameters inherently make it the better machine? Like an engine with more cylinders?
That's a super common assumption. Think of parameters as the total number of connections the model can make. It's like its vocabulary, its exposure to concepts, its potential depth.
Okay, so more is better?
A model with more parameters has a vastly higher potential, yes. But potential is not performance.
Oh, interesting.
Having a billion parameters doesn't guarantee a better output if the input, meaning the specific interaction you are having with it in that moment, is flawed.
Because the interaction is what guides it.
Exactly. The interaction is everything because it tells those trillions of parameters how to arrange themselves.
So the hardware analogy is just totally broken, which means we need a new framework to actually understand how these things behave.
And that brings us right back to Banerjee's alternative, which is brilliantly simple.
The classroom?
Yes, the classroom is the perfect metaphor here,
Why is that?
because it forces us to deal with inconsistency. And inconsistency is like the defining trait of interacting with AI.
Yeah, Banerjee writes that in any classroom, different students have different strengths, and no student performs best all the time.
Which is just so true to life.
It really is. And if we apply that to LLMs, it completely reframes the frustration that, you and I feel every single day.
Oh, totally.
It's like having an English prodigy who just completely freezes during a calculus test, or, I don't know, a highly creative student who just happens to test incredibly poorly on a Tuesday morning pop quiz.
Right. And in a real school setting, you would never, ever slap a universal grade F on that student's forehead just because they failed one specific type of assignment.
Because we recognize that human intelligence isn't just a single flat line.
Exactly. It's textured. It has peaks and valleys.
But we absolutely do that with AI all the time.
Oh, constantly.
Like if the model writes a beautiful, nuanced email for me on Monday, but then, it hallucinates a bunch of fake numbers when I ask it to summarize a spreadsheet on Tuesday.
We just throw our hands up.
We do! We declare the AI is terrible. We assume it's just broken.
And we assume it's broken because we are still thinking like we're holding a calculator.
Right, the hardware mindset again.
Exactly. But the student metaphor explains this inherent inconsistency. These models do not have static performance levels. They have contextual strengths and contextual weaknesses.
So one model might be, like, incredibly proficient at logical deduction and writing code.
But then completely struggle to adopt a warm, empathetic tone for a customer service email.
Which means we are essentially managing a classroom of highly capable but deeply uneven students.
Precisely. And in a classroom, the performance of the student isn't just about the student's innate brain power or their total number of quote-unquote parameters.
Right.
The output of a student is a collaborative outcome. It requires guidance.
And this lands us at the absolute core of Banerjee's argument. If these models are inconsistent students with wildly varying strengths, then the defining variable for success isn't actually the model itself.
No, it's not.
The defining variable is the instruction it receives.
The teaching.
Yes. Banerjee states clearly that none of these models perform well without good teaching. The exact same model will give you completely different results depending entirely on how you guide it.
It's a huge mental shift.
It's a massive identity shift for us. I mean, for decades, software companies have conditioned us to view ourselves as users.
We are consumers of technology.
Right. But Banerjee is arguing that we need to completely abandon that identity. We have to view ourselves as teachers.
Yeah, and think about the physical posture and the mental approach of a user. A user demands a product. You click a button, you expect the machine to dispense the result.
It's a vending machine mindset.
Exactly. You put your dollar in, you press B4, and you expect your soda to drop.
And if the soda gets stuck, you shake the machine. You get mad at the hardware.
You don't try to teach the vending machine. But a teacher, however, doesn't demand a product. A teacher guides a process.
Right.
A teacher inherently understands that the final essay turned in by the student is heavily dependent on how well the teacher explained the assignment in the first place.
Like how clearly they set the boundaries or what kind of rubric they provided up front.
Exactly.
Okay, hold on. I want to challenge this a bit.
Go ahead.
I totally understand the philosophical shift, but practically speaking, I am paying a $20 monthly subscription to a multi-billion-dollar tech company for this tool.
Right. A lot of people feel this way.
Why is it my fault if their highly advanced trillion-parameter AI gives me a generic, terrible marketing plan? Shouldn't the machine be smart enough to figure out what I want? Why do I have to do all the heavy lifting of teaching it?
That right there is the most common friction point people have with this technology.
Because it feels like work.
It does, but think of it this way. It's like hiring a Michelin star chef.
Okay.
But instead of giving them a fully stocked kitchen, a specific menu, and, information about your guests' dietary restrictions, you just lock them in a dark room with a bag of flour and some water.
Oh, wow. Okay.
And then when they hand you a bland piece of flatbread, you get mad. You say, I paid for a Michelin star chef. Why didn't I get a souffle?
Well, because I didn't give them the ingredients or the direction. I just gave them a really vague demand.
Exactly. The AI has the capacity to be that chef. It has the parameters, the training, the probabilistic capability.
But without my specific guidance.
So without your specific structured guidance, it just defaults to the most generic, safe, statistically average output possible. That is exactly what a bland flatbread prompt gets you.
Okay, I love the chef analogy, but let's get really practical for the listener here.
Sure.
When I am staring at a blinking cursor on my screen, what does being a teacher actually look like? How do I stop being a vending machine user and start being a process guiding teacher?
It changes the entire anatomy of your input.
Yeah.
So let's look at how a user approaches that marketing plan you mentioned earlier.
Okay.
A user simply types, write a marketing plan for my shoe company.
Very standard prompt.
Right. And the AI spits out a generic, boring 5-point list. The user reads it, rolls their eyes, and says, ugh, this model is bad. I need to wait for the next update.
Right, they blame the machine for getting stuck.
Now look at how a teacher approaches that exact same task. A teacher types, you are acting as a senior marketing strategist. Our shoe company focuses on sustainable materials for urban commuters. Your goal is to draft a 3-phase marketing plan. Focus heavily on digital community building and avoid traditional print media. Before you write the plan, outline your core strategy so I can review it.
Okay, let's break down the anatomy of what you just did there, because that is vastly different from write a marketing plan. What makes that a teaching framework?
Notice the specific mechanical steps. First, I gave the model a role. You are a senior marketing strategist.
Right.
In a probabilistic engine, assigning a role immediately narrows the mathematical possibilities.
Yeah.
It forces the AI to pull from the vocabulary and frameworks associated with high-level strategy rather than just, generic internet chatter.
You essentially told the student what class they are sitting in. Like, this isn't an art class, this is an MBA seminar.
That's a great way to put it, exactly.
Sure.
Second, I gave it constraints and context. Sustainable materials for urban commuters, and avoid print media.
So the AI now has guardrails. It knows what the boundaries of the assignment actually are.
Yes.
Mm-hmm.
And third, and this is honestly the most crucial part of being a teacher, I asked it to show its work.
Outline your core strategy so I can review it.
Right. I am not asking for the final product yet. I am guiding the process.
That is a total revelation. By asking for the outline first, you are allowing the AI to establish its own internal logic before it generates the final text.
Yes, and you are giving yourself the opportunity to grade the rough draft. If the outline is wrong, you can correct the student before they spend energy writing the entire essay.
Which honestly proves why those standardized benchmarks tech companies release are so incredibly deceiving.
Oh, absolutely.
Like, when a company announces, our new model scored 10% higher on the standardized legal bar exam benchmark, they are testing that model in an absolute vacuum.
Right. They're using highly optimized, meticulously crafted prompts designed by professional prompt engineers.
They are showing you the student's performance under absolutely perfect, laboratory-controlled teaching conditions.
Yeah.
But that tells me absolutely nothing about how the model will perform in my messy, imperfect reality. When I am sitting at my desk, distracted, firing off a quick, poorly phrased question with zero context.
The benchmark is totally irrelevant.
Right.
Because the bottleneck in that messy reality isn't the model's parameters. The bottleneck is the pedagogy. The bottleneck is the human.
And recognizing our role as teachers forces us to take absolute responsibility for the output, which leads us to Banerjee's ultimate paradigm shift.
This is the big one.
The text poses a question that basically flips the entire industry on its head. So maybe the question isn't which model is best, it's how well are we teaching the system?
That is the pivot. It takes the burden of performance away from the software developers in Silicon Valley and places it directly onto our own shoulders.
I have to admit, that is a deeply uncomfortable mirror to look into.
It really is.
If I get a terrible, robotic-sounding, cliched draft from my AI, it is much easier for my ego to just say, well, the AI is stupid today. Blaming myself requires work.
It absolutely protects our ego to blame the machine. But let's look at the actual cost of that mindset.
Okay.
If you blame the machine, you are rendering yourself completely helpless. You are stuck. You're literally just sitting at your desk waiting for some tech giant to release Model C or Model D before your workflow can improve.
You become a passive victim of the software's current limitations.
Exactly. You're just waiting.
I'm just sitting around waiting for a progress bar to finish downloading a better brain.
Right. But if you accept Banerjee's premise, if you accept that you are the teacher and the output is a direct reflection of your teaching, that is incredibly empowering.
Because I can do something about it.
Yes. It means you have agency today. You do not have to wait for the next generation of artificial intelligence to get better results.
Wow.
By simply improving your own ability to teach how you guide the AI, how you provide context, how you iterate and correct its mistakes, you can unlock entirely different levels of performance from the exact tools you already have access to right now.
That completely changes the ceiling of the technology. Like, the ceiling of the AI isn't hard-coded into its algorithms. The ceiling of the AI is tied directly to my own skill as a communicator.
Which turns interacting with AI into a deeply humanistic skill.
Yeah,
It is no longer just about knowing how to code or understanding computer science. It is about empathy. It is about clarity of thought. It is about patience and articulation.
that makes so much sense.
The best, quote-unquote, teachers of AI are people who know how to break down complex tasks into digestible steps, who provide constructive feedback, and who can just communicate their intent with crystal clarity.
Which are exactly the same skills that make someone a great human manager or a wonderful school teacher.
Exactly. The AI is just holding up a mirror to your own clarity of thought. If your prompt is muddy, confused, and lacking context, the AI's response will be muddy, confused, and generic.
Because it's a student?
It is a highly obedient student trying desperately to decipher a terrible assignment sheet.
A highly obedient student deciphering a terrible assignment sheet. That is like the perfect way to visualize it.
Right.
So when we see people online arguing for hours in comment sections about whether they should subscribe to Model A or Model B, they are fundamentally having the wrong conversation.
They're arguing about whether a number 2 pencil or a mechanical pencil will make them a better novelist.
Oh, that's brilliant. It's the illusion of the tool. Now, to be fair, though, models do improve, right? Like, we see structural advancements. A larger model with more recent training data will have a broader knowledge base.
Oh, absolutely. The baseline of the student's capability rises over time. The acoustic potential of the instrument gets better, so to speak. But for the vast majority of us, using these tools for daily cognitive work, writing emails, analyzing data, drafting proposals, we are nowhere near maxing out the acoustic potential of the models we already have.
We're playing chopsticks on a grand piano and complaining about the sound quality.
Exactly. The bottleneck is our pedagogy.
Let's quickly recap the journey we've just been on today, because it is quite a paradigm shift from where we started.
It really is.
We began by looking at our ingrained habit of evaluating AI through a hardware lens. We want spec sheets. We want to point at the car with the most horsepower and just declare it the winner.
We want the comfort of a binary, static metric for something that is inherently dynamic and probabilistic.
Right. And then Banerjee's text forced us to throw that entire hardware mindset out the window and step into the classroom.
Yeah.
We had to embrace the messy, unpredictable reality that these large language models are like students. They have wild inconsistencies, they have brilliant contextual strengths, and glaring, frustrating weaknesses.
And most importantly, they absolutely require guidance to shine.
Which means we had to fire ourselves from our comfortable jobs as passive users and hire ourselves as active teachers.
We have to stop shaking the vending machine when it doesn't drop the perfect answer on the first try.
Yes. We have to start taking responsibility for guiding the learning process. It is entirely on us to provide the role, the boundaries, the context, and the feedback. We have to outline the strategy before demanding the final essay.
And like we said, it's an empowering realization because it puts the control of the output back in your hands.
Yeah.
You don't have to wait for the future. You just have to communicate better in the present.
Banerjee actually ends their note with a direct question, and I want to pass that exact question on to you listening right now.
That's a great question to reflect on.
It is. The question is, curious, have you seen the same model perform completely differently based on how you interact with it?
I'm sure everyone has.
I highly encourage you to reflect on your own recent teaching moments with AI. Think about the last time you got really frustrated with a generic or incorrect response. Were you being a good teacher who provided clear rubrics and context? Or were you being an impatient user demanding a souffle from a bag of flour?
It is a very confronting exercise if you are honest with yourself about how much effort you actually put into the prompt.
It really is. We started this deep dive talking about the comfort of the spec sheet. We want our technology to be clear, definitive, and flawlessly obedient right out of the box.
But learning isn't a spec sheet. Learning is a conversation. It is a collaborative process of discovery and refinement.
And that leaves us with one final lingering thought to mull over today.
What's that?
If these large language models are truly like students, and their performance relies entirely on our human teaching skills, What happens to the boundaries of artificial intelligence if our students are ultimately just limited by our own human blind spots as teachers?
Oh, wow. That is the ultimate tension of this entire technological era, isn't it?
Are we actually on the verge of building true superintelligence? Or are we just holding up a giant, very expensive digital mirror to our own pedagogical flaws?
Right.
If the AI can only ever be as good, as clear, and as articulate as the human guiding it, maybe the ceiling of artificial intelligence isn't made of silicon at all. Maybe the ceiling is us.
That is definitely something to think about the next time you open a blank prompt window and wonder why the machine isn't reading your mind.
We will leave you with that to chew on. Thanks for joining us on this deep dive. Keep questioning the benchmarks and happy teaching.